system in Canadian homes. Are houses too airtight? No, they aren't. Fresh air circulation is essential to prevent mold and mildew in today's modern energy-efficient homes, so heat recovery ventilation, HRV, or energy recovery ventilation, ERV, is fitted. Homes built in the last 40 years in Canada are relatively airtight. Before that, we generally relied on leaky uninsulated walls to provide fresh air and prevent mold and mildew, and they did that very well. Cost and comfort had us adding insulation, but not necessarily sealing our walls. The folly of this was quickly realized, and vapor barriers became a part of the building envelope shortly thereafter. Vapor barriers stopped the flow of moist air through walls. This of course led to a buildup of moisture in homes, and condensation on windows was commonplace and hard to stop. This led to a buildup of mold and mildew in homes. Modern-day airtight homes need mechanical assistance to stop moisture damage and protect indoor air quality, especially true in basements where ventilation is essential to stop mold forming. There are still those that profess that walls need to breathe and that houses are too airtight, but this myth is completely false and very damaging to your home. Walls need to be able to dry, ideally in both directions. Natural air flow. If you hold a door open a crack in winter, natural convection will draw air in at the bottom and force it out at the top. Your home will behave in a similar way. This is called the stack effect. Warm air rises, forcing air out the top portion of your home and drawing in cold air from the bottom to replace it. How much air will be changed depends on how well sealed your home is. While natural convection will offer a certain amount of new air, with most new homes it just isn't sufficient. Properly sealed homes require mechanical ventilation systems to remove moisture and provide sufficient fresh air for occupants. Ventilation systems. What is an HRV? Mechanical ventilation systems are known as heat exchangers, HVACs, heating, ventilation, and air conditioning, or HRVs, heat recovery ventilators. The point of these systems is to remove moisture and provide fresh air to your home that is preheated by the outgoing air. The core of an HRV has small separated channels that air passes through, allowing incoming air to be preheated by exhaust air. There are no heating coils, you are simply operating fans, so they are relatively cheap to run. And you will certainly save money overall, as heating moist air eats up a lot of energy. Depending on the quality of the machine you buy, you can expect to recoup anywhere from 50% of the heat in the air, to as much as 95%. Plan on spending around $2,000 installed, that's for a reasonably efficient one. Double that for the high-end models with aluminum cores that conduct heat better than plastic ones do. Ventilation systems. What is an ERV? Energy recovery ventilation, ERV, is the process of exchanging the energy contained in normally fan-extracted stale or humid air from homes and using it to treat, precondition, the incoming outdoor fresh air in residential and commercial HVAC systems. During warmer days, an ERV system precools and dehumidifies, while in the winter season ERV systems humidify and preheat incoming air from outside the house. One benefit of using energy recovery in the USA is the ability to meet the ASHRAE ventilation and energy standards, while improving indoor air quality and reducing total HVAC ratings and energy requirements. ERV technology is not only an effective means of reducing energy cost and heating and cooling loads, but allows for smaller equipment. Additionally, ERV systems allow for maintaining the ideal relative humidity of 40% to 50% in indoor home environments. This range can be maintained under more or less all conditions, with the only energy penalty being the electric for the blower to overcome the pressure drop in the system. Indoor air quality is important for many reasons. Preventing moisture issues such as rot and mold. Preventing damage to windows from condensation. Preventing respiratory illnesses caused by interior contaminants. Reducing heating costs by not heating excess water vapor which will leak from your home. Ideal humidity levels. Along with removing contaminants from the air, there are health consequences from having either too much or too little moisture in our homes. There are bacteria, viruses, molds, and mites that will show up on either end of the spectrum if your air is either too humid or too dry. Somewhere in the range of 35 to 50% relative humidity is generally assumed to be the best for avoiding most health risks and irritants. It's high enough that you won't have cracked furniture, chapped lips, or constant nosebleeds, and it's not too damp for comfort, condensation, or heat consumption. If you are in an older home, don't panic. What we write in these pages is meant to inspire ideas and solutions, not fear and anxiety. If you feel good, your air smells good and your windows aren't dripping, relax. For peace of mind, consider buying a hydrometer to measure your indoor relative humidity, which will cost you maybe $20 to $30 at most hardware stores. If you have an issue, crack your window a bit for now until you sort it out. Humidifiers, dehumidifiers, and air purifiers are available to deal with some of these issues. A dehumidifier will cost between $200 and $300 to purchase, and maybe $10 to $15 a month to operate. This added cost will likely be negated by heat savings, as heating moist air requires a lot more energy than heating dry air. If you plan to undertake an HRV or ERV installation project yourself, do your research first to determine proper vent placement. An intake in the bathroom rather than a simple exhaust fan, for example, will mean heated incoming air instead of just creating negative pressure and letting cold air find its own way in every time someone turns on the fan. You won't need to install a bathroom fan, of course, if you have an intake in there. Just be sure to put a timer switch so you and your guests can turn it on. Having an intake in or near the kitchen helps pick up general moisture and contaminants, but don't hook it up to your stove hood. It's not a good idea to send cooking grease through an expensive heat exchanger. And as for installing duct work, the flexible tubes are cheaper and easier to work with, but can be quite noisy and the ribs slow air movement, forcing your air exchanger to work harder. Since your fresh air vents are best located in living areas and bedrooms, you might find that it's well worth the added cost of solid ducts simply for noise reduction.